Now let's go over example 2. In example 2, we're going to actually find a regression. Now we have done, this is the third time we're doing regressions. We do need a separate regression for exponentials and for logs. So the instructions to make these is first, make a scatter plot. Then, if we're making an exponential regression, this is the regression we will type. So we'll do y sub 1 tilde ab to the x sub 1 power. Now, weirdly enough, when we do exponentials, you do need to make sure that this little box right here saying log mode is checked. Okay. Weirdly, when you go to logs, you have the same log mode. It does not change your regression if you click it or unclick it. So it doesn't matter with logs, but with exponentials, log mode has to be checked. So then for log regressions, this will be our regression here. So y sub 1 tilde a plus b natural log of x sub 1. And we do need to remember that when we are doing logs, that our logs cannot have an input or an x that equals 0. Okay, so can't kind of keep that in mind. So example 2. The table shows the total personal income of the United States in millions of dollars for selected years of 1960 and projected to 2024. Find the best fitting exponential function. So it's going to tell you, you're not having to pick between these two. It's going to tell you which function to use. So find the best exponential function that will model the data with x equal to the number of years after 1960. And let me do this so it's not all running in together. Otherwise, I underline basically the entire problem. Okay, so they're telling me best fitting exponential function. Best fitting means a regression. They're telling me exponential. They've told me X is the number of years, double underline after 1960. And then my Y is my value of billions of dollars. We're going to round to 3 decimal places as needed. So if my X is equal to 1960, then this right here needs to start at 0. And so this is what I mean. Be careful. If this said best fitting log, I would actually not want that 0 because logs can't equal 0. So you're going to have a question like that where you have to take away that input of 0 to make that log work. So keep that in mind. So then 1970 would be 10. 1980 is 20. And we are not going to assume it counts by tens. So 1990, great year, 30. 2000 would be 40. Here's why I'm not just assuming. Now it's going from 2000 to 2008. That's now 48. We're not increasing by tens anymore. So then 2014, we're increasing here by 6. So this is 54. Now we're increasing by 4. So this is 58. And now we're increasing again here by 6. So 64. So it's all over the place. I've been warning you with regressions not to just assume that however the pattern starts, that that's how it keeps going. You want to pay attention to those numbers and make sure they're increasing consistently. And if not, do the math, right? So 2024 minus 1960 will get you 64. Okay, and then our Y column is good. So let's make the scatter plot real quick. Guess I could have kept that, huh? Let's redo that. Okay. All right, so 0, 10, and here goes to 48. And now it's not guessing anymore. It's like, what are you doing? Let me move this. Okay. All right. Right from the get-go, we made a mistake, so that's not good. Okay, my dyslexia is coming in strong today. Our instructions tell us after we input those to check them, and I definitely want to check it because I messed up on the first two. So check all your numbers. If even one of these numbers is just slightly off, your regression is not going to be right. You're going to be mad you have to do it again. Okay, looks like I made all my mistakes up at the front. So that's nice. So once I have all of that data put in and I have checked it, hit zoom and we can see our function right here. And it does say exponential, and that looks like it's a good model. Kind of started off slow and now it's starting to really kind of shoot up right there. So now that I have that, I'm going to go into this next line because it says exponential. I'm going to type in this regression right here. So y sub 1 tilde ab to the x sub 1 power. Now you can see here, it has this box right here for log mode. You do have to make sure it is checked with this. You can see these numbers here, and it's going to change them quite dramatically, especially A when we change it. Okay. All right. So then, three decimal places. So A is about 533.57. That 7 makes that 9 go up. So you need to think of 69, or like that number is 69. So 69 goes up to 70. And then B is 1.065. Okay, if my regression or my exponential is A times B to the X, then this means my regression is 533.75 times 1.065 to the X power. It does not matter where that X goes. So you can see here I wrote it inside the parentheses. Here I wrote it outside the parentheses. I didn't really mean to do that, but it does not matter where that X goes. You do need to make sure you have parentheses separating your A and your B though. Okay. Now part B says if the model is valid in 2025, what is the projected total personal income then? So remember, model. So while this is a more accurate regression, to get to my model, in line 3, I'm going to type this in. Okay. I'm going to go ahead and unclick that one. Y equals. Okay. So there is my model. And it is asking me if the model is valid in 2025, what is the projected total income then? So let me go in a different color so it doesn't get all muffled together. In 2025, we're talking about X because X is the number of years after 1960. And so subtract the 2. 2025 minus 1960. And that gives me 65. Okay, so now in line 4, we'll do x equals 25. And we get an intersection point. Let's check 25. Okay. I think that's a little better. Let me check this real quick. I'm losing my mind, guys. That equals 65. So I don't know why I'm going with 25 here. Okay. Lord. Okay, 65. Okay, that's going to be way up here. And so that will then give me y equals, it doesn't tell me how to round because we're talking about personal income. We're talking about money. Let's go to the nearest cent. So 31,982.76. Is my answer there. Now in C, it asks the opposite thing. In what year? So what does that tell me I am looking for? This tells me I am looking. I'm looking for X here. In what year does the reported model again? So that tells me in line 3, we are keeping the model we found in part A. What does the model predict the total personal income will reach this 44.147 trillion? Okay, slight problem here. First, is this going to represent my X or my Y? That is my Y. So in line 4, we will put Y equals, but time out. It's not this number here. This one is telling me 44.147 trillion. But what is my Y in? Y is in billions. Billions. So my units are a little bit off. So all you need to do here is move your decimal over 3 spots. So you'll move it over 1, 2, 3. And so this will be 44,147. Because now that is in billions. Do this in red just so it matches. Okay. So we will put in y equals 44,147. Okay, where is it? Well, it's not up high enough, right? If I go up here, find that intersection. And that gives me x equals 70.1. So that's about 70. And if it wants to know in what year, we add that to our 1960. And that would be in 2030. because again, it's 1960 plus 70. Now, you know how my math lab is with these regressions. I'm going to go ahead and put in here, or is it 2031? Sometimes it will just want you to round and we'll say 70.1 is 70. So this is the year, but other times it will say we are all the way through year 70 plus a 10th of that next year. And so we're in 2031. So if you're confident in your regression and you change the model, you move the decimal and it doesn't take this and you're confident in it, go up to the next one.